Welcome to this new stage of this video on the routing, and we are talking today about the part 2. And as we are talking about the routing by distance vector, today we understand more about routing by distance vector and the open shorted path first concerning routing. A router using a distance vector routing protocol does not know the full path of the destination network. The router only knows the following. 1. The direction of interface in which the packet are to be transferred, the distance to the destination network. The receiving node thus learn who its neighbor is able to reach and what it costs. Each router periodically broadcasts to its neighbor its routing table. Update the table on the receiver. If the receiver table contains an entry that is not in its table, add this entry in its table with the cost equal to receive plus cost of the reception link of the table. If the table receive contains an entry already present, it updates its entry if no cost superior, or if the cost is superior calculated cost, or if the no cost to change value. This is the different condition that help the router to take a destination. Now, about the link state routing, remove vector routing problem. The only information that a router knows is the cost to reach each destination. In this case, conversion can be long large network principle of link state routing. Each router must discover the neighboring router and the network address and determine the cost for each neighbor. Build a spatial package containing the address, the neighbor address, and the cost to reach. Send this package to all other routers. You calculate the shortest path to each router from the cost matrix. The link state routing. Each router has a complete view of the network topology from distributed information. The cost matrix is built from information received from other routers. The topology is constructed from the cost matrix, and the router table is built from the graph. In practice, discovery of neighbor sending a special package, what we call yellow, to which neighbor respond with their identity, measurement of the cost of the line, sending a special package echo which is immediately returned by the neighbor. A timer measure A and R time regardless of the load of the link in the time curve. Build link state package at regular interval or when an important event occurs. Packet distribution flooding with packet numbering and packet age. Calculating of the new table using the Djousse algorithm. And this is the presentation concerning those different link stage. So the link stage here will concern the sequence. Maybe we will take, for example, the case of the router A. It will have a sequence and the time, that is the age that it will took to reach the different other router. And we have also the link state present here. Those different routers, for them to communicate now, in A, as you are seeing here, this will be the link state routing among all those devices. That is called A, B, C, D, and F. And they will have the sequence and the age and the direction and the distance that they will took. The open shortest path first protocol. The link state routing protocol that has been developed to replace the router information protocol distance vector is Open shortest path first is a classless routing protocol that uses the zone concept for scalability on the reference 2328 define of open shortest path metric as an arbitrary value named cost. Cisco Internet Operating System use bandwidth as a open shortest path cost metric. The main advantage of open shortest path first is over routing information protocol are rapid convergence and scalability throughout the implementation of much larger network. Now, historically, in 1989, the specification of Open Shortest Path First version 1 protocol was published in the reference 1131. To implement where described one run of router. The other on Unix workstation, this later became a widespread Unix process known as GATE. Open Shortest Path First version 1 was an experimental routing protocol that was never be deployed. In 1991, Open Shortest Path version 2 was introduced in the reference 1247 by John Moy. This protocol offers significant technical improvement over the Open Shortest Path First version 1. At the same time, ISO was working on the link state routing protocol on their own. The ES protocol immediate system to intermediate system. Not surprisingly, ETF choose to recommend the Open Shortest Path First as interior gateway protocol in IGP. And in 1998, the Open Shortest Path First version 2 specifier was updated in reference 2328, which still the current document for Open Shortest Path First. In 1919, the Open Shortest Path version 3 for IP version 6 was published in the reference of 2740, written by John Moy, Rob Colton, and Dennis Ferguson. Alright, encapsulation. The Open Shortest Path First packet headed is included in every Shortest Path First packet, regardless of its type. The Open Shortest packet headed and type specified data, then encapsulated in the IP packet. In the IP packet header, the protocol field is set to 89 to indicate the Open Shortest Path First, and the destination address is set to one of the following: to multicast address, to 224.0.0.5 or 224.0.0.6. If the Open Shortest Path First is encapsulated in an internet frame, the destination MAC address is also a multicast address. That it will be as follows. Now, the message of Open Shortest Path First encapsulated will be represented like this. You have the header, the packet IP header, the OS Open Shortest Path First header, and some specific data in the type of Open Shortest Path package. Now, the type of package that we can see in this domain will be the hello. It establishes and maintains contiguity with other Open Shortest Path router. The DBD contains a abbreviated list of the sender router link state database and is used by destination router to control the local link state database. And the LRC, destination router can be request more information and any DBD entry by sending a link state request that we call LSR package. The LSU, link state update. Link state update are used to respond to link state request, as well as announce new information. Link state updates contain 7 different types of link state advertisement and link state acknowledgement. When received and link state update packet, the router send a link state acknowledgement packet to confirm that is successfully reception. And this is what will be described. We have the type 1 up to the type 5, and we have here the name of the packet and the description that we found inside that packet. For example, we have the description database, that is a DBD. And first of all, let us see the case of yellow. In the yellow is the discovery of neighboring and the continuity among them. And here we have the description of database to verify the synchronization of database among the router. And here we have the request link state that will ask the record of link state of specific link state of the router to another router. And we have now the update link state that will send those record link state to specific demand. And we have the reception accuser that we call the acknowledge link state that will make sure that every reception is showing that has been received. And the package format, this is the package format that we have. We have the header of the train and the header of the IP and the header of the open shortest path first and the header of the yellow packet. This is the description of the things. All right, right now let us describe the content of those packages. The important fields shown in the diagram include the type, open shortest path first, yellow 1, DBD2, LRC, LSU, LSAC on 5. The router ID will be the source of router ID, the zone of origin of the packet, the network maps, subnet maps associated with the sending interface, and yellow interval, that the number of seconds between the sender router yellows interval, the router priority used in the selection of the designer router or designer backup router, designer router DR, that is the router ID if it's applicable, and the designer backup router, the BDR, backup designer router ID if applicable, and the neighbor list specify the OSPP router ID of the neighbor router. Now, neighbor detection. Open shortest path first, routers send yellow packet across all open shortest path interface to determine if there are neighbor on those links. Receive a yellow open shortest path packet conform to a router that there is another open shortest path router on the link. Router must agree on 3 values. 1. The yellow interval indicates the frequency with which an open shortest path router sends yellow packet. Generally, we have 10 seconds by default and 30 seconds on the NBMA access segment. In that interval, during which the router will wait to receive a yellow package before declaring the neighbor out of service, we have 40 seconds and 120 seconds for NBMA network. The type of network. The open shortest path defines 5 types of network: point-to-point multi-access with RAM rows, NBA access, point-to-point multi-point, and virtual links. This is the 5 stage that the open shortest path network define. The abhorrence SP5. Now, each open shortest path router maintains a link state database containing the link state acknowledge received from all router. Once a router has received a LCA and create its local link state database open shortest path, use disregard shortest path algorithm that is called SPF to create a SPF tree that we call a spanning tree, shortest path first tree. The shortest path first tree is used to provide the IP routing table with best path to each network. This is the representation of it. Here we have those routers with their serial connectivity, router 1 and router 2, and here we have the database of link stage. That is the representation database of link stage, and here we have the algorithm of shortest path first, and we have what we call the spanning tree, the shortest path tree. So, and we have is routing table here. Right now, this is the topology that represents all what we are saying. This is one example of topology to show what we are saying here. We have the periphery, router 1, router 2, router 3, the interface that is here with the faceted and serial, the different IP address, and the subnet and the mask subnetting. Okay, open shortest path router configuration. What happened now? With open shortest path router configuration, we need to understand that open shortest path is enabled using the global configuration command. The global configuration command that will be inside the process ID. The process ID is between 1 and 65,535 chosen by the network administrator. The process ID has only a local meaning, which means that it does not match other open shortest path router to establish contiguity with neighbor unlike EIGRP. The network command enable OSP on all interfaces that belong to the specific network associated interface. Now send the receive routing interface information protocol update. Announce the network specify in routing information protocol routing. Update sent to other router every 30 seconds. And the syntax is here. Router configuration network and network address, generic area ID. Configuration of router. The next page is the open shortest path command use a combination of network address wildcard mask. This generic mask can be configured as the inverse of subnet mask for an interface, and the subnet mask that is under 24 or 255.255.255.240 inverted the subnet mask giving generic mask 0.0.0.15. Area ID referred to the open shortest path area. An open shortest path is a group of routers that share link state information. All shortest path first router in the same zone must have the same information in their link state database. And the open shortest path router ID. We need to identify each router uniquely in the open shortest path router domain. Cisco router define the router ID using 3 criteria according to the property below. 1. Using the IP address configured with the router ID command of the open shortest path protocol. 2. If router ID is not configured, the router choose the highest IP address from each IP loopback interface. If no loopback interface is configured, the router choose the highest active IP address from its physical interface. 3. To check the router ID, you can use the show IP protocol command. Some version of OS is not display the router ID. In this case, use the show IP open shortest path first command to check the router ID. The router ID can be changed by setting another IP address using the router ID open shortest path command, followed by the router Djousse clear IP open shortest path process command. When duplicates are detected on open shortest path router IDs, OS display a message of the type % open shortest path or dub retrieve detected the router with duplicate router ID. This is the command. Now, to verify the open shortest path first, we have the following. The show IP open shortest neighbor command can be used to check and repair open shortest neighbor relationship. For each neighbor, this command displays the following: neighbor ID, ID of the neighbor router. A pre is the open shortest priority of the interface. This subject is dealt with in a later section. a state. Operator refers first state of the interface. Full state you mean that the router and its neighbor have identical operational link state database. Dead time. The length of time that the router will wait for a neighbor operator fast yellow packet before declaring the neighbor out of service. This value is reset when the interface receives a yellow packet. IP address of the neighbor interface to which this router is directly connected. Interface on which this router has established an adjacency with its neighbor. And two routers cannot establish an open shortest path contiguity if the submask do not match. Placing router on separate network. Operator fast yellow counter or stop counter do not match. Operator fast network type do not match. The operator fast network command is missing or incorrect. In the interest, operator fast troubleshooting command include show IP protocol display in the operator fast process ID and the router ID, the network that the router advised the neighbor from which the router receive update, and the default administrative distance. Show IP operator fast can also be used to examine the router ID and the operator fast process ID, display the operator fast zone information as well as the last time the SPF algorithm was calculated. It showed the IP of operator fast interface quickest way to check yellow and dead interval, and the cost value concerning Cisco. At each router, the cost of the interface is determined by the computing from 10 to power 8 divided by the bandwidth in bit per second. The result of calling reference bandwidth, by default, the bandwidth is 10 to the power 8 or 100 billion per second or 100 megabyte per second. The result, interface with a bandwidth with 100 megabyte per second and above have the same operator fast cost 1. The reference bandwidth can be modified to accommodate network with link faster than 1 billion byte. 100 megabyte using the operator fast auto cost referred to bandwidth command. So we can have those different type. In those type interface, we have fast Ethernet, that is the more faster, the internet, the E1, E2, and every other in this power 8. Okay, this is the topology that represents those different value of cost that we have here. We have the router 1, the router 2, the router 3, and we have the different costs, and we have the speed of the transaction that are among them. This is how it would take. This is the cost 1. This is the cost 64. This is the cost that is more expensive. The default bandwidth in serial interface. On Cisco router, many router and many serial have the default TE bandwidth value. This bandwidth value does not really affect the speed of the link. The bandwidth command is used to change the bandwidth value used by the EOS in the operator fast metric cost calculation. And the syntax will be the router config bandwidth kilobyte per second. Caution, you need to understand here that this value does not change the actual bandwidth of the connection. It just changes the result of the operator fast calculation. The IP operator fast command can directly configure the cost of interface. The syntax will be router 1 config if in the privilege mode, and operator fast cost will be 1562. The multiple access network. The LSA or multiple access network may represent two challenges for operator fast, creating multiple contiguity for one for each pair of router, a massive release link state advancement, creating a adjacency between each pair of router in the network, and will create unnecessary number of contiguity. Excessive LSA will flow between router in the same network. 5 router present the network require only 10 contiguity, but 10 router will require 45 contiguity. For 20 router, you will have 119 contiguity. And this is the example of those contiguities. So the formula that we can do will be the number of contiguity is equal to n, the value of n minus 1 per 2, where n is the number of router. And for example, 5 router, we will have 5 minus 1 multiplied by 2. That will give us 10 contiguity. The multiple access network. There is one solution designed for designer router. Operator first select designer router as the point of the collection and deliver a link state advertisement, send and receive. A backup designer router is also chosen in the case of failure of the designer router. All other router became DRODA, and the either designer router or backup designer router. The DRODA send the link state advertisement only on the designer router, and the backup designer router using the multicast address of 224.0.0.6. All designer router, the backup designer router is also listening. The designer router responds for transmitting a link state advertisement to other router. It uses the multicast address. Only router provide broadcast of all link state advertisement in the multiple access network. The designer router, this is the router which the highest operator fast interface priority. The backup designer router, this is the router whose operator fast interface property is the second highest value. If the operator fast interface priority are the same, the highest router ID will prevail. They control the choice of the designer router, standing backup router via the IP operator fast priority interface. The command is provide better control over operator fast multiple access network, and the syntax will be router config in the priority mode, operator priority 0 up to 255. The value 0 represents the selection as if it is the designer router or the backup designer router. For example, let's imagine this architecture with all router interconnected here, and this is the basic architecture as you are seeing here. And now all the router in this architecture will become neighbor. So there will be exchange packet yellow and link stage advancement and other link stage. In this case, will represent a huge open shortest fast traffic as you are seeing here in the picture. You have the huge open shortest fast package here, and the solution will be what? We need our router to elect a conductor so that each router will send its update only to a ladder. This one will have the load of putting the update to the other router. This role is called the designer router. For example, this is the designer router that we represent here. All right, and now if this router come down, someone need to be ready to replace it. This router will be called the backup designer router. So if directly this our router got bad, we must have a backup designer router that is already settled. The designer router and the backup designer router role will only be implemented if our router are linked to one another through level 2 equipment and share the same range of IP address. If our operator fast network is only point to point, there will be no designer router and backup designer router role. The default route interface and interval. Like router information protocol, open shortest path first require the default information original command to advertise the default static route to 0.0.0/0 to other router in the zone. If the default information original command is not used, the default 40 rule will not be broadcast to other router in the operator fast zone, and the syntax will be like this: router 1 config default information originate. And now the date and the hello operator fast forward interval can be changed manually using the following interface command: router config IP operator fast yellow interval second, and the router config IP operator fast dead interval second. Caution: remember that yellow and dead operator fast first intervals must be identical between the neighbor. Okay, thank you for seeing this session of this tutorial. Thank you to watch it clear, and see you during the next passage. Thank you very much.